Good morning, students. In the previous session, I had taught you a new type of differentiation which we call it as logarithmic differentiation. That is, if the function is expressed in such a form where the base and the index both of them are functions of x, then directly we cannot differentiate. We take the logarithm on both the sides, then applying the laws of the logarithm we simplify the function, then we go for the differentiation. Or sometimes if a function is too much complicated, multiplication, division, raising to certain power of the function, like that if you are having, then also by taking the logarithm the function becomes a little bit simpler, so that you can do the differentiation. And we have worked out some problems. In today's session also I am going to work out the problem which are connected with the logarithmic differentiation. So here let me take the first problem as find dy by dx, that is the instruction. Find dy by dx, y is equal to root of x minus 1 into x minus 2 divided by x minus 3 into x minus 4 into x minus 5. Now this is a function. That is, in the previous session I had considered one algebraic function, I remember, x plus 2 whole square into x plus 3 whole something like that. Linear factors, they were raised to some power. Then by taking the logarithm, applying the first law and the third law of logarithm, the entire expression, entire function could be expressed in one line, one statement. By taking the then differentiating, we got the answer. Whereas here, of course, these are also linear terms only. It is in the form of a quotient, but we are taking root of the number. What do you mean by root of any, square root of any number means that function raised to the power 1 by 2. Suppose it is cube root raised to the power 1 by 3, square root raised to the power 1 by 2, fourth root raised to the power 1 by 4. So here first let me write it in the index form, that is x minus 1 into x minus 2 divided by x minus 3 into x minus 4 into x minus 5, whole thing taken to the power half. Because if you write in this form, then it is easier for you to take the logarithm, apply the law of the logarithm, and then we can go for differentiation. Now take logarithms. Of course, you have to write here, take logarithms. Take logarithms. Now left hand side, same thing, it is log of y. Right hand side, log of x minus 1 into x minus 2 whole thing divided by x minus 3 into x minus 4 into x minus 5, whole thing raised to the power half. Whole thing raised to the power half. Now first here all the first three laws of logarithm have to be applied to simplify the function on the right hand side. Here take it as one function, log of some function raised to the power half. So it is of the form log m to the power n. So log m to the power n means you can write it as n into log m, that is that index half becomes the coefficient. So first let me write that one. Therefore we have log y would be equal to half of log of x minus 1 into x minus 2 divided by x minus 3 into x minus 4 into x minus 5. Each step you do only one calculation, apply one law. So first what I have done, I have considered the third law of logarithm, log of m to the power n. So that is n into log m. That is the first step. Next, see, look, that is over. Now come to the function inside the bracket. It is of the form log of m by n. It is in the form of a quotient. Therefore, we apply the second law of logarithm, log m minus log n. So this is half of, write like this, log of m. M means it is numerator. X minus 1 into x minus 2, better use another bracket. Then minus log of the denominator x minus 3 into x minus 4 into x minus 5. Why I am using so many brackets is, here we are having a product. So, logarithm of a product, there also logarithm of a product. So, we have used the third law, we have used the second law. Now, it is a product means it is of the form log of m into n, that is log m plus log n. So, now you write it as half of log of m plus log of n, log of x minus 1 plus log of x minus 2. Same rule is applicable here also, log of x minus 3 plus log of x minus 4 plus log of x minus 5. But remember, we are having a minus sign. So, all the terms have to be multiplied by the minus sign, hence all of them they become negative. Minus log of x minus 3 minus log of x minus 4 minus log of x minus 5. Close the bracket. So, we have used the third law, the second law and the first law, and we have come to the particular stage where we can use the differentiate the function. Therefore, log y is equal to all those things right here. Log y would be equal to half of all this expression. Now, what we have to do? Differentiate with respect to x. Differentiate with respect to x. As usual, left hand side is 1 by y into dy by dx. Right hand side, keep that half as it is. Now look, all of them are logarithmic function. Log of some function. What's the derivative of log x? It is 1 by x. Now it is 1 over x minus 1. Now the of course it's a composite function. The derivative of x is 1. For 1 it is 0 because it's a linear term. Therefore, that 1 need not be written. Next is plus 1 by x minus 2. Same procedure. Minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. So, this is the derivative of the given function. Now, next step is you have to take this y to the right hand side. Don't take the LCM or anything. Too many terms are there. Keep them as they are. So, the next stage is you get the value of dy by dx by taking that y which is on the left hand side to the right hand side. Therefore, you write dy by dx would be y divided by 2. Need not write what is y. It is 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. Now, this is the derivative of the function. So, here whenever we have a little bit complicated function, you can directly differentiate. It is not, I am not saying it is not possible, certainly you can differentiate. Y is equal to something means we apply the chain rule, product rule, quotient rule. All the three rules have to be applied to arrive at the derivative of the function. So, same answer you will be getting, but it is done in a different way. Here what we do is using the same three laws. There we apply chain rule and product rule, quotient rule. Here we are applying the first law, second law and third law. So that now the function the function is expressed in one line here, only one statement. So it is easier to do the differentiation. That is the purpose of using the logarithm to simplify the function in such problems. So when the base and the index, both of them are functions of x, we take the logarithm, or if it is a little bit complicated function that is given, by taking the logarithm, the function becomes little bit simpler so that you can go for differentiation easily. Now, another problem of the same type. Y is equal to square root of x minus 3 into x square plus 4 whole thing divided by 3x square plus 4x plus 5. Same procedure. Here also we are having a function, an algebraic function of course, under the radical sign. under the radical sign we are having. So, how do you differentiate? Before even now I am telling you, you can use the, say, root of something means 1 over 2 root of something. Then apply the quotient rule. For the numerator part, you can apply the product rule. Certainly, you can get the derivative of this one, but that would be little bit difficult. So, first, as in the earlier problem, I write it as to the power half, because it is the square root which has been given to us. Right? Take it to the power half. So, square root of any function can be written as that function raised to the power 1 by 2 or half. Now, take logarithms. These are lengthy problems, so can be expected for a higher mark question. Take logarithms, that is log y would be equal to half of logarithm of the right hand side, half of log of x minus 3 into x square plus 4 divided by 3x square plus 4x plus 5. This is what we are having, half of log of the entire expression. Just like the previous problem, look here. So, we have made use of the third law of logarithm. So, a log of m to the power n is n into log m. So, this is n in this case into log of the given function. Now, this function is a product here, and on the whole it is a quotient. So, first look at it as a quotient. So, we can apply the second law of logarithm. Then it says that log y would be equal to half of log of the numerator, that is x minus 3 into x square plus 4. I am using another bracket because there are two terms in that one. Then minus log of 3x square plus 4x plus 5. 3x square plus 4x plus 5. So, this is how first step. First we applied the third law, now we have applied the second law. Now, that is single term, no problem. Here there are two terms, apply the first law of logarithm, log of m into n would be log m plus log n. So, then only you can do the differentiation. So, log y would be equal to half of log of x minus 3 plus log of x square plus 4 minus log of 3x square plus 4x plus 5. So, these are the terms remaining after the after applying the three laws of the logarithm. Now, finally, we have come to that particular position where we can go for differentiation. So, here we are having log y equal to half of log of x minus 3 plus log of x square plus 4 minus log of 3x square plus 4x plus 5. Now, we have to differentiate. Write this one. Differentiate with respect to x. Differentiate with respect to x. Okay. Now, left hand side our usual answer, that is 1 by y into dy by dx. Right hand side, keep that half as it is. Go one by one. Log of x minus 3. Log of anything is 1 over that function. 1 by x minus 3. Again, x minus 3 has to be differentiated, whose derivative is 1. So, I am not writing that one. Next one, log of x square plus 4. That is again 1 by x square plus 4. Now, it is a function x square plus 4. So, we have to differentiate this one. In this case, no, the derivative was 1, I did not write. Here x square plus 4 means, for x square, what is the derivative? 2x. For 4 being a constant, it is 0. Therefore, into 2x minus last one, 1 by 3x square plus 4x plus 5. That is, log of any function is 1 by that function. Now, again, this function it's a composite function. So, you have to multiply by the derivative. 3 into x square becomes 2x. and then 4 into 1, that is 4. For 5 it is 0, being a single constant. Now let me rewrite this one taking y to the right hand side. So it becomes y by 2 of, I am writing the answer in a proper way, that is 2x divided by x square plus 4 minus 6x plus 4 divided by 3x square plus 4x plus 5. Now this is the derivative of the function. So this is how we have to solve the problem when we have got a complicated algebraic function. It need not be algebraic, it may contain the trigonometric function also, as we have seen in one of the in the previous session. In one particular problem we had a product of trigonometric functions only. Now this is the procedure we adopt. So in all these problems, what I did in this session and some problems in the previous session, you might have observed that we had y is equal to only one term. It may be a product also, but there was only one term here. But it was not a sum or difference of two or more functions like this. Now here onwards, now I am considering some functions which have been expressed as either the sum of the two functions or the difference of the two functions. Now see, we have learnt the first three laws of logarithm. It is log of m into n is log m plus log n, correct? Then log of m by n is log of m minus log of n, isn't it? We have a rule for the product, we have a rule for the quotient, but we do not have, there is no rule as such, log of m plus n like this. Log of m plus n or log of m minus n is not equal to log of m plus log of n or log of m minus log of n. It is not so. Only a product can be expressed as the sum of the two logarithmic terms, and the quotient can be expressed as the difference of the two logarithmic terms. Understand? So here, suppose the function is given as a sum or difference of two or more functions, directly you cannot take the logarithm as we did in these problems. Log y you cannot write directly. But still we apply the law of the logarithm, logarithmic differentiation procedure only to arrive at the derivative of the given function. So I am considering such functions now. First let me take, let y be equal to sin x whole to the power x, first one, second term plus sin inverse of root x, sin inverse of root x. Don't take logarithm here, that is one common mistake usually students do, I have observed. So don't take logarithm, you cannot take the logarithm. Now y equal to sin x to the power x, whole power x, sin inverse root x. Of course this is a inverse trigonometric function, it is not a simple function, it is a composite function. We have learnt in the earlier sessions about finding the derivative of the inverse trigonometric function even if it is a composite function. So you can directly differentiate this, but this you cannot apply the logarithm here. In such problems, no, this is the method we adopt. So write here either in the main column or in the working column, let u be equal to sin x whole to the power x and let v be equal to sin inverse of root x. You have to make two assumptions here. You have to make two assumptions. Usually we take them as u and v. First one u, second one v. Of course the second function directly could be differentiated, whereas look at the first function, sin x whole to the power x. Here base and the index, both of them are functions of x. Therefore we cannot directly differentiate. So what was the procedure we had adopted? We had adopted the logarithmic differentiation method to arrive at the derivative of such functions. The same procedure we are doing only for this function because it is of that particular form. So here the concept of the logarithmic differentiation comes into picture. On the whole, you cannot take the logarithm there. So here what I do is, so let us come to this function. Therefore, y becomes u plus v. Y becomes u plus v. Now differentiate with respect to x. Differentiate with respect to x. It is dy by dx will be equal to du by dx plus dv by dx. It is the first step always you have to do. Whenever there are two functions here, so assume them separately as two different functions. Then write it here. Then differentiate with respect to x. It will be dy by dx equal to du by dx. If plus is there plus or minus is there minus plus dv by dx. Now take this as the result 1. Don't ever take the logarithm directly in the given function when it is in this particular form. Now come to this part. Here you have to take the logarithm. Now take logarithm. Take logarithm. Therefore, on the left hand side as usual, whatever we were doing for y, we are doing for u, that's all. Log u would be equal to, this is the index, x into log of sin x. Or you can write log sin x to the power x, x becomes the coefficient. Since you have done such problems, I am directly writing. Now differentiate with respect to x. So log u becomes 1 by u into du by dx. Now here you have to apply the product rule as usual. First function x into derivative of log of sin x. It is a composite function. Log of anything is 1 over that function, 1 by sin x. For sin x it is cos x plus first function into the derivative of the second plus second function log of sin x into derivative of x is 1. Derivative of x is 1. Now cos x by sin x is cot x. Therefore, you can write it as du by dx is, take u to the right hand side. But what is u you have to write? See, du we have made the assumption in the final answer, u has to be replaced by the original function. So u into means, u means it is sin x whole to the power x into, right inside the bracket, x into cos x by sin x is cot x plus log of sin x. Log of sin x. Now this is the derivative of the first part of the problem. Now come to the second part of the problem. Here, of course, even that if that function were also of the same type, then you should have taken the logarithm there. Whereas for this particular function, it is an inverse trigonometric function but a composite function. Therefore, directly I can write the derivative. dv by dx equal to, what is the derivative of sin inverse x? 1 by root of 1 minus x square. Write that one. 1 by root of 1 minus whatever function is there, square that one. So sin inverse part is over. For root x, it is 1 by 2 root x. Correct? So it is a combination, composite function. Now root x whole square is x. Write it in the proper position. 2 into root x into root of 1 minus x. So this is dv by dx, this is du by dx. So we calculate them separately. So we have made the assumption u and v for two functions. Or this may be u, this may be v, it does not make any difference. Ultimately we will be getting the same answer. So we have differentiated both u and v using the logarithmic differentiation. In this problem we have directly differentiated. So after getting this one, what you have to write is substitute in 1. Substitute in 1. That is why I given a number for that one. Substitute in 1, we have dy by dx equal to, what is du by dx you write? Sin x whole to the power x into x cot x plus log of sin x. It is the first term. Plus, we have got the other one, right? 1 by 2 into root x into root of 1 minus x. So, it's quite a lengthy procedure we are adopting here, because instead of having one function, we are having a combination of 2 or sometimes 3 functions. So, what we have to do? Individually, you take them separately as u and v. Then, applying the logarithmic differentiation procedure, you differentiate each one individually. And finally, you come to the original function, wherever du by dx and dv by dx are there, substitute these values, that we will be getting the actual result here. Now, this is the procedure we adopt to get the derivative of the function if it is expressed in the form of sum or difference of 2 functions. Usually 2 functions would be there, 3 is not given so far. Now, let me move on to another problem. Y is equal to, here you have to be careful, because I am giving you the logarithmic function, too many logarithmic terms are there. Log x whole to the power x plus x to the power log x. We do not have any function other than log x here. So, y is equal to log x whole power x plus x to the power log x. Now, as usual, we have to make assumption here. Let u be equal to log x to the power x. Similarly, let me make the assumption for v. Let v be equal to x to the power log x. X to the power log x. Now, in the earlier problem, for one I took the logarithm, the other term I could differentiate directly, because it was in the one of the standard forms. Whereas here, for both of them, you have to apply the logarithmic differentiation procedure. So, take logarithms. Take logarithm, then log u on the left hand side. Here this x becomes the coefficient, this is the base. So, we have log of log x. Be careful here, log u would be equal to x into log of log x. Now, next procedure is we have to differentiate with respect to x. So, log u becomes, as you know, 1 by u into du by dx. Y is there 1 by y, u is there 1 by u. Now, here carefully apply the product rule, x into, see this is a composite function, log of log x. First I take this logarithmic function, log of anything is 1 by that thing, that is 1 by log x. So, this is over. Come to this one, because it is a composite function. For log x it is again 1 by x plus second function log of log x into derivative of x is 1. So, this x and x they get cancelled, taking u to the right hand side, and what is u that has to be written, that is log x whole to the power x into, it is what is remaining inside the bracket, you write 1 by log x plus log of log x. Now, this is the value of du by dx. Now, let me come to the other part, that is here also the same procedure, you have to take the logarithm. See, look here, better write one more step, log x to the power log x. Here x is the base, log x is the index. See, in the previous one, log x was the base, x was the index. So, x into log of log x, whereas here log of x to the power log x. Whole of log x itself is the index. So, that becomes the coefficient. Therefore, we have log x comes here. Log m to the power n is n into log m. So, log x is this index and this is the base function, log x. This is special type. Special type means it is different from the previous one. Log x into log x. Either you can apply the product rule, or you can take it as log x the whole square. When you apply the product rule, both of them would be simple function, whereas here it has become a composite function. Now differentiate with respect to x. So log v is 1 by v, and for v it is dv by dx. Look here. Here I am using the chain rule because it is a composite function. Log x the whole square, something to the power n, n into x to the power n minus 1. 2 into log x to the power 2 minus 1, that is simply log x. 2 into log x. Now index part is over. For base, if you differentiate, it becomes 1 by x. Therefore, taking v to the right hand side, dv by dx. And what is v? You have to write that one. It is x to the power log x into 2 into log x whole thing divided by x. Now this is the value of dv by dx. So what did you hear? Both the functions are little bit complicated. So we have taken them separately as u and v, and applying the logarithmic differentiation procedure, we have differentiated both the functions. Now right, we have made the assumption, therefore the given function, you have to write that sentence, the given function can be written as y is equal to u plus v. Now on differentiation, dy by dx equal to du by dx plus dv by dx. Okay. Now these two derivatives which are calculated separately should be written side by side. If you stop here, you don't get the last one mark may be cut for that one. Now write the actual derivatives which are already calculated. First one, it is log x whole to the power x into 1 by log x plus log of log x. Now this is the derivative of the first part of the function. Now let me write the second part where it was denoted as v. What is v? Plus, you write x to the power log x into 2 into log x whole thing divided by x. Now this is the value of dv by dx. That is why always make the assumptions u and v and then differentiate. You will be getting dy by dx equal to du by dx plus dv by dx. Take it as result 1, then calculate the derivatives individually. After calculation of the derivatives individually, finally if you are given a number 1 there, substitute in 1, we get the result here. So this is the procedure. I told you when the two terms are there, it is quite a lengthy procedure, but you have to be careful about the differentiation part of the function. Now some more problems I want to work out to complete this particular topic, that is logarithmic differentiation procedure, and I will take up that in the next class, next session. So go through all these problems, whatever problems I have done in this session, go through them and carefully understand each and every step. Then we can work out some more problems in the coming session, and then we can conclude this particular topic. Afterwards, now I am teaching you another new type of function which is called as implicit function. See, all these words you have not heard at all. Logarithmic differentiation is one procedure. Implicit function is the next type of function. You are going to find the derivative of that function. Afterwards, there is another function called as parametric function. So we have to go in the same order. First you have to learn about the composite function, then we learn about that inverse trigonometric function, because we use the knowledge of composite function, then the logarithmic differentiation, implicit as well as the parametric function. Then we can move on to the second derivative. So we will meet in the next session to discuss about some more problems on this particular topic, that is logarithmic differentiation. Thank you.